Hi, my name is Bob. I'm with the Deck Store. Today we're going to talk about some really basic LED circuits. We're going to utilize an LED or a 30-watt power supply. A power supply converts 110 volts AC power. If you read the label, in this case it produces 30 watts of 12-volt DC current. We're going to show you how a couple tools will work for you and save you a ton of time. We're going to work with some gel-filled wire nuts. These are really great because it keeps the moisture out of the connections. And we're going to talk about some UR connectors. These connectors were originally developed for the telecommunication industry, telephone systems, but they also work really, really well with low voltage systems. So the specific type of circuit we're going to do today is called a loop circuit. So imagine you've got the wire that's going to run around your deck, and this is a cable. This is an 18-2 cable, and I'll show you why it's called that in a second. But it's going to start at the power supply, it's going to go around the entire perimeter of your deck, and it's going to return to the power supply. So let's go ahead and strip off the cable, the sheathing off the cable. We're going to use this cutter, and this is going to simply break that connection. And notice inside you've got two wires, an 18-gauge wire on each side. On this one, and we're going to do the very same thing. Now these wires are all color-coded. Out of the power supply, you've got a blue wire and a brown wire, excuse me. The brown wire, the label tells us, is the positive lead, the blue is the negative lead. On these wires, we're going to have a positive and a negative. The black wire is typically used as your negative lead. So to use these type of connectors, we have to strip these cables. Watch how easy it is with this tool. We simply put on the wire into the proper gauge stripper, compress it, and it strips off. Now you can buy these strippers on our website. You can get them at a number of local hardware stores. Wherever you get them, they're priceless. So now we've got our wires all stripped. So what I'm going to do, remember, it's a constant piece of wire. It could be 100 feet long going around your deck. I'm going to simply join my two negative wires together and my two positive wires together. And then I'm going to hook them up to my power supply. Remember, our black and blues are our negatives. And I remember that because black and blue is an easy combination to remember. So if it's black and blue, it's negative. That's a bad thing. And if it's red, it's hot. And if it's brown, it's hot. The electricity itself really doesn't care what combination you're doing, but if somebody's going to troubleshoot a system, they're going to want to keep the colors straight. And we're going to put on these gel-filled wire nuts to make that waterproof connection and seal them up. So look what we've got. We've got a power supply where the power comes out, it goes through the cord like electricity, and it comes back and returns to the beginning of the power supply. So when we plug it in, absolutely nothing happens because we don't have any devices or fixtures on this wire to separate that electricity. So let's go ahead and talk about the fixtures. We've got some rope lights, we've got some post cap lights, we've just got an LED light chip. It doesn't matter, they all work the same way. So let's use this one because this will be the most visual. Again, we have a white and a black wire on it. The white is the same as the red, the black is the same as the other black or the blue. So let's go ahead and let's cut our loop circuit. Imagine this is a post or a junction on your deck. Let's go ahead and cut that. And when you ran it, you may have run it in segments. That's not going to matter. We're going to strip the wire, the casing off the cable. Now what's neat about these red UR connectors, we get to skip a step. We no longer have to strip the actual individual wire inside the cable. Because they've got 3 holes and we've got 4 cables here plus our cable in this end, we can simply join all the blacks together and then the red and the whites together on this hand. So now we're going to have 3 connectors in each hand. We're going to take our red UR connector. Now notice these pliers, they're not just ordinary wire cutters. They don't quite go together on the top. They'll cut wire, of course, but you're going to slide each one of these wires into a separate slot on the bottom of this connector, and you're going to push them all the way in until they come to the head of the connector. And you can use the tip of these pliers to compress them to the point where the gel extrudes from the bottom. The next set we do the exact same thing with. We get 3 wires. I cut them clean to make it easier to put in. I slide my wires into the connector. I push them to the head and I crimp it. It's as easy as that. You can visually tell that those connections are properly made because you can see that the wires go to the heads and you can see the detail. So when we plug this in, if we did everything right, this should illuminate. And there you go. Now here's the advantage of a DC loop circuit. Remember, it was a circle that went around the deck. We simply carried it through our connections. Watch what happens when Mr. Bad Squirrel, we got a lot of them in our market, comes around and he chews through your wire. You don't lose power to your circuit. The power can simply flow the other direction. Now we can take and repair that circuit and cut the other line and get the very same results. Or we can simply add another device by stripping the cables and adding a device, or simply patching them and repairing our connection where the cut was made. And let's go ahead and do that. We're going to just throw in a red UR connector, join our two reds, because these are quick and easy. We'll go ahead and fix this damage, but you wouldn't have got a service call for just the one break because nobody's going to know what happened. The other advantage to a loop circuit is it's going to keep the lights all the same intensity. With DC power, the farther you get from the power source, the dimmer the lights become. Well, in this case, it makes them all the same distance from the power source. It's not like a Christmas tree string of lights where if one goes out, they all go out. It's a loop circuit, and it's in parallel connection. So now we've repaired this side, so let's go ahead and cut the other side and see what happens. Our lights stayed illuminated just as we'd expect it to do. You'd have to actually physically cut the lights in two different spots to make your circuit break. That's Bob from the Dexter. Thanks again.